All right, so here we go with today's lesson, which is multiplying polynomials. So now exponents will change. Yesterday we were just combining like terms. Today we'll be multiplying. Exponents will change. So an old school method here from back when Mr. Warner was in school is called FOIL. If you ask your parents, they probably remember what FOIL is. Okay, so I'm going to demonstrate that method. I'm also going to demonstrate another method for you. So FOIL means first, outer, inner, last. So we multiply the first terms together first. So x times x is x squared. Then we multiply the outer terms, x times 4, and that's 4x. Then we multiply the inner terms, 2 times x is 2x. And then we multiply the last terms, 2 times 4 is 8. All right, and then when we finish, we combine like terms. We write it in standard form, which is highest to lowest, so x squared plus 6x plus 8. Because these are the only two like terms that we have, and this is our best answer. Okay, now there's another way to do this multiplication, and that's called a generic rectangle. Some of you are going to say, oh, that looks like a lattice from 6th grade. All right, it sort of is, but sort of not. So what we're going to do is draw ourselves, okay, a generic rectangle. It's a 2 by 2 because this has two terms. This is a binomial, and this is a binomial. I'm going to write my terms next to my rectangle, okay? So 2x plus 1 and x minus 5. And then what this really is a multiplication table, a times table. I'm timesing everything to get the inside of the box. So 2x times x is 2x squared, okay? And then let's say x times 1 is 1x, right? And then let's say 2x times negative 5 is negative 5x. And then finally we have 1 times negative 5, and that's negative 5. Okay, so that looks a little messy with the colors, but I was trying to code it for you so you can see which two multiply for which boxes, but it works like a times table. And then we simply just write what's left on the inside of the boxes for our answer. So 2x squared, and I have like terms here, 1x, okay, and negative 5x, so that's minus 4x, and then minus 5, my best answer. So Mr. Warner doesn't really care what method you use, but those are the two methods that we use when we're multiplying polynomials. All right, so I'm going to walk you through some of these examples here. We're not going to do all of them, okay, but you should copy down the ones that I do, and then you'll work on the rest of the time to work on your homework and so forth. All right, so I'm going to work the left-hand side here using FOIL. So first, y times y, y squared. Outer, y times 1, 1y. All right, 8 times y, inner, 8y. 8 times 1, last, 8. Combine like terms, y squared plus 9y plus 8. If I'm going too fast, you can certainly pause, rewind, or whatever you need to do, all right, to catch up. Next one here, same thing. First, 4x times x, 4x squared. Outer, 4x times 3, 12x. Inner, negative 7 times x, negative 7x. Last, negative 7 times 3, negative 21. All right, I combine my like terms. I get 4x squared plus 5x minus 21. Best answer. All right, and the last one here on this page. Okay, first, 8h times 3h, 24h squared. All right, 8h times negative 1 is negative 8h. Negative 3 times 3h is minus 9h. Negative 3 times negative 1 is plus 3. So 24h squared minus 17h plus 3 is my best answer. Now, on this side over here, I'm going to go through and do these using the generic rectangle. All right, again, I don't care which method you use. I encourage you to choose a method and always use the same one to get used to it. All right, so k minus 4, k plus 5, and then it's a times table. I'm multiplying to get the insides of the rectangle. So k times k is k squared. K times minus 4 is minus 4k. 5 times k is 5k, and 5 times negative 4 is negative 20. And then I write this out, combining my like terms as I go. There's my like terms. So I get k squared plus 1k minus 20. All right, just going to keep repeating this. Hopefully you're following along, writing things down. Obviously, if it's going too fast, you can pause anytime you want. All right, this is all part of what you're turning into me. So n minus 1, 5n minus 4. Then I'm going to write the insides of the rectangle, 5n squared minus 5n minus 4n plus 4. So 5n squared minus 9n plus 4. There you go. Not too bad, not too bad. All right, here we go. Last one, another rectangle. So, all right. And even if you're not going to choose this as your favorite method, I'd still like you to be writing these notes down. All right, and then when it comes time for homework, you can choose your favorite method. Okay, so we have 3w times 3w is 9w squared. 3w times 1 is 3w. 3w times negative 1 is minus 3w, and 1 times negative 1 is negative 1. So now, when I combine my like terms, I get 3w and minus 3w. That actually makes a 0, so I end up with only having a binomial, 9w squared minus 1. It's actually a special one that we'll come back to in a couple days. All right. Okay, so this doesn't get any more difficult, okay, with these. All right, you see this x plus 4 squared. Trick there is to remember what that squared means. Okay, that means x plus 4 times x plus 4. Okay, same thing over here. All right, and then you get these down here that are binomial times a trinomial. So let's do those two together, and then we'll call it a day for the notes portion. All right, I can still use FOIL. It's just too many letters to make a word out of it. Okay, so really what this is distributive property. I'm going to distribute the first term, which is the x term, to all three of the terms in the second parenthesis. So x times x squared, x cubed, x times 3x, 3x squared, x times negative 6, negative 6x. And then I'm going to distribute the second number, okay, or the second part of the binomial, 4, to all three terms. So 4 times x squared is 4x squared. 4 times 3x is 12x. And 4 times negative 6 is negative 24. So you're double distributing. That's really what you're doing there, double distributing. Then I'm going to combine my like terms. So x cubed has nothing to be combined with. 3x squared and 4x squared is 7x squared. Negative 6x and 12x is positive 6x and minus 24. Best answer. So obviously, the larger the polynomials that we multiply together, the larger the answer for the polynomial that we get. All right, and finally, what if I wanted to use the rectangle for that one? Okay, because I have a binomial and a trinomial, I'm going to do a 2 by 3 now. Okay, rectangle. So k minus 5, k squared minus k minus 8. Same principles all apply here. All right, it's a times table. I'm timesing everything to get the answers in the boxes. So k to the third, all right, k squared times negative 5 is negative 5k squared. Negative k times k is negative k squared. All right, negative k times negative 5 is positive 5k. Negative 8 times k is negative 8k. And negative 8 times negative 5 is positive 40. Now I have two sets of like terms, right? So I have like terms here and like terms here. So when I combine those together and write my answer, I get k to the third minus 6k squared minus 3k plus 40. All right, those are the most difficult ones you'll have to do. Okay, so what I'd like you to do down here in the homework, okay, in the practice, what we got there, 3 by 4, that's 12 problems, plus 25 is a bonus problem. Let's do, let's see here, don't forget these couple here, right, are, like this is x plus 4 times x plus 4, so don't forget that. All right, use that to do the other ones in that row. Okay. So of those 12 problems there, all right, I want you to choose 9. Okay, so you can skip 3. Skip any 3 you want for full credit. If you do all 12, I'll give you extra credit. Okay, so choose 9. Okay. All right. And if you do finish all this and submit it, or you could just save it and show it to me when I get back today, if I get back before class is over, or if I come back when I come back tomorrow, you can show it to me then. Doesn't matter to me. But if you do finish all those items, then I think everybody has missing work that they could work on. If not, you can just work on stuff for another class.